Alright, what's up everybody? What is up everybody? This is Mr. Loken again. And this is the lesson video for 4.6. 4.6 is all about isosceles triangles. And if you remember, isosceles triangles is a triangle where two of those sides are congruent. Right? It's one of those, we classify triangles, and there are three ways we classify triangles. Isosceles is just one of those. Alright, so we'll talk about different parts and what we can figure out and what we know about isosceles triangles. Alright, so what we're starting with is what's called a vertex angle. If you look at this triangle here, we call this angle the vertex angle. Alright, it's the angle that's formed by the two congruent sides. Alright, so remember those tick marks. Tick marks tell that those are equivalent. Those lengths are the same. And that angle is called the vertex. Alright, and then it also says the base angle. So the vertex angle is this angle, and then the base angle are the two other angles, right? Or the angles that are opposite the vertex angle. Alright, so next we have what's called the isosceles triangle theorem, and that just tells us if two sides are the same, that means their angles are the same. Alright, so think about it. You have the two congruent sides. The angles opposite of those sides are equivalent to each other. Alright, so if we look, another way of saying it, the angles I'm all over the place right now. The angle besides the vertex angles are the same. Alright, so the two angles that are not the vertex angles are the same if you have an isosceles triangle. Alright, so that's what the isosceles triangle theorem says, and written out in this proof kind of right here. If AB and CB are congruent, then that means angle A and C are the same. Alright, and then we have what's called, well, it's actually the same name, isosceles triangle theorem. It's just reversed. Alright, that tells us if we're given that these two angles are the same, that means that these sides are congruent. Alright, so it's just the opposite. What this theorem was telling us is if these lengths are the same, that means the angles are the same. What the other theorem says is if we're given that the angles are the same, then we can conclude that those sides are the same, like that. Alright, we do that. Alright, so moving on to an example, and this is an exact question that you will, this is the exact type of question that you will have. I even remember taking MCAs and ACTs and getting just blasted with these types of questions. Alright, so these are important that you know this. Alright, so and these are definitely questions that will be on the test, this type of stuff. So it tells us if DE and CD are congruent. I'm going to mark that out. It's always a good idea. And then it also tells us BC and AC are congruent. I'm going to write 2 there. And we're given that CDE. So this angle is 120. We have to somehow figure out BAC, or this angle there. Alright, so we're just given that both those triangles are isosceles, and then we have to somehow figure out that missing angle. Alright, so if you look at, we're just going to focus on this DEC triangle first. What our isosceles triangle theorem told us is that if these sides are the same, that means these angles are equivalent. Alright, and also we know that all triangles, the angles added up together equal 180. That's what we did in 4.2. So if we know that all these angles added up together would give us 180, and this one's 120, that means there's only 60 left over. Alright, which means this angle would be 30. This angle would also be 30. Alright, so that's one part of information that we know, and then using that we can actually figure out what this angle is. Alright, because remember this angle and this angle, we call those vertical angles. And vertical angles are always the same. Alright, and then next knowing that, we have another triangle here. And we know the angles, like I mentioned earlier, are always adding up to 180. So if this angle is 30, that means this angle plus this angle added up together with that 30 would give us 180. Alright, so what you need to do, you would need to go 180 minus 30, which would give us 150. So that means that's 150 between those two sides, between those two angles. But we're also given that it's an isosceles triangle, which means that these angles would be the same, which means that both those angles added up together would give us 150. Alright, so that tells us this angle is 75, and that one's also 75. Alright, so all that work to tell us that that angle there is 75 degrees. Alright, we're just kind of using all these different theorems and all these different skills and facts we know about triangles to kind of make our own triangles and figure out the missing angle measurement. A lot of it depends on if you know that the angles added up together give you 180. Alright, it's always a trick, always a good trick to use those types of questions. Next, we have properties of an equilateral triangle. First, it says a triangle is equilateral if and only if it is equiangular. Alright, so in order for it to be equilateral, that means it has to be equiangular. Alright, so if it's an equilateral triangle, that means all three of these angles will be 60 degrees. Alright, each angle of an equilateral triangle measures 60 degrees. Alright, so all equilateral triangles, the angles are always 60 degrees. Moving on. Next, it says triangle EFG is equilateral. That means all three of those sides are the same. And then it says EF. It's actually supposed to say EH. Sorry. I don't know why it says EF. EH bisects angle E. Remember what that tells us is if it bisects, that means these angles are the exact same. Alright, that's what the definition of bisect. Alright, it splits that angle into two equal parts. Alright, so it also tells us that it is equilateral. And using the information we just figured out, if it's an equilateral triangle, that means all three of these angles are going to be 60 degrees. Alright, so if that means this entire angle is 60 degrees and it's bisected, that means each of these sides is going to be 30, and this is going to be 30 as well. Right? So the question is asking you to find the measure of angle 1 and measure of angle 2. I'm just going to write measure of angle 1 equals 30, and the measure of angle 2 would also give us 30. Alright, it's bisected, it's split into two. Alright, next, if I'm rushing through this, you can always pause the video and write this stuff down. Alright, next we have to find x and then also measure of angle 1 and 2. So it gives us the same scenario that these sides are equilateral. That means all three of these angles are going to be the same. They're all going to be 60. Alright, we have to find what x is, and we also have to figure out what measure of angle 1 and angle 2 is. Alright, so what we would need to do is let's see. So we can't just assume that it's being bisected like the last problem had us do. So what we would need to do is I'm going to look at this triangle first. Alright, I know that that angle there is equal to 60 plus 6x plus 9x. And those three angles added up together give us 180. Alright, it's a triangle. You know those angles added up together give us 180. So we're just going to solve for x right here. Alright, so we go 60 plus 15x equals 180. Subtract 60 from both sides and you get 15x equals 120. And I should know that. What is it? X equals 8. Alright, so that tells us that x equals 8. I'm just going to write that here. X equals 8. So it didn't actually get bisected. So that's why we needed to write that stuff down. Next, we want to figure out, well, I'm just going to write this is 6 times 8 is 48. That means that angle 2 here would be 12. Alright, because remember 48 plus 12, it needs to add up to 60. Alright, and then moving on down here to 9x. 9 times 8 would give us 72. Alright, and then since this is a straight angle, that means angle 1 would have to be 180 minus 72, which would be 108. Alright, so I'm going to write that here. 108 and what did I say? 12. There you go. Circle answers like that. Perfect. Alright, so there is that. That's that last question that we were talking about. And so yeah, that is it for 4-6. Big thing for 4-6. You scroll back to that first page. This is the big thing. It's an isosceles triangle. That means if these two sides are equivalent, that means these angles are the same. Alright, it's the angles besides the vertex angle are always the same. Alright, so that's it for isosceles triangles. If you have any questions, let me know and I can help you out. Alright, thanks for listening. Peace.